So what makes this a phase contrast microscope? Well, maybe you can see here a little bit. It's got this thing here which has the phase plate in it. It has a little adjuster here. This one says pH 2, for instance, and if I scroll this over, it clicks and says pH 1. There's something that says DF for dark field. There's 0, which is light microscopy. And there's a pH 4. And each of these pHs refers to phase 3, phase 4, phase 1. And this ring has to match what it says on the objective. So this objective here is the 40x objective. And what does it say? I'm going to find it. It says pH 3 at the bottom. That means I have to make sure this is set to pH 3 in order to have the phase equipment here match the rings that are in the actual objective. Otherwise, you won't see anything. It'll just look like a light scattered mess. Okay? These scopes should be in phase, meaning they should be ready to look through them and be able to see contrast. Sometimes they're not, and what you do is adjust. Usually there's knobs. Here's this silver knob here. This knob, you turn it back and forth and adjust the phase. There's another one on the other side that you adjust. So as you're looking through at your sample, you adjust these until you get the image to look just right. Now that's sort of the old school way to do it. There's actually a specific instrument called a phase telescope that you actually put into, you remove an ocular, and you actually put the phase telescope into this position, look through it, and you can actually see the phase rings, and you adjust them with these knobs down here, and you can get them so that they actually line up on each other perfectly, and you know your scope is in phase. The rest is just like any other light microscope.